Today I am going to present my digital logic circuit project titled ICU bed monitoring system. The project is designed to monitor ICU bed availability automatically using digital logic circuit. The system counts patient entering and leaving the ICU and display whether beds are available or full. The project includes counters, sensors, comparators, 7-segment display, timers, and efficient design. According to my ID calculation, the ICU bed capacity is 8. Now I will explain the inputs and process of the system. First, the inputs: entry and exit sensor detect patients entering and leaving the hospital. Equipment input in used to input the maximum available beds. Now the process. Asynchronous up and down counter counts patient using the entry and exit sensor. A 7-segment display control circuit handles the output display. And then now the output section. If the ICU reaches full capacity, the 7-segment display shows full. Otherwise, the display shows beds available in blinking mode when beds are available. And the page shows the block diagram of the ICU bed monitoring system. Here, entry and exit sensor provide input to the synchronous counter. The counter keeps track of patient numbers. Register 1 stores entered and cited patient information. Register 2 store maximum bed capacity. A comparator compares current patient with maximum capacity. The capacity becomes full, the display shows full. Otherwise, the display shows beds available. This is the flowchart of the system operation. First, the system start, then entry and exit sensor detect patient movement. If a patient enters, the counter increases. If a patient exits, the counter decreases. If counter equals 8, the display shows full. If counter is less than 8, the display shows beds available. The page contains the truth table for the synchronous up and down counter. The ICU capacity is 8, so 8-bit synchronous counter is used. The table shows clock pulse, up and down operation, binary outputs from Q3 to Q0. The counter increases when patient enters and decreases patient leave. Now the circuit diagram. The page shows the circuit diagram of the up and down counter. The design uses JK flip-flop connected together to create a synchronous counter. The logic equation for J and K input are used to show there. This equation control counting operation for both up counting and down counting modes. Now I will explain the timer calculation. From the given values, frequency calculate is 12 Hz. Duty cycle is calculated at 60%. The calculation are required for generating the blinking display signal. Time calculation, the page shows the detailed timing calculations of the total period of approximately 83.33 millisecond. On time is about 49.998 millisecond and off time is about 33.332 millisecond. Using capacitor value 50 microfarad, resistor value R2 is calculated approximately 962 ohm. Here is the value of the resistor R1 is calculated. The result is approximately 480 ohm. The resistor values confirm that frequency remains near 12 Hz, duty cycle remains near 60%. The page shows the 555 timer circuit. Two timers are used. One control display timing, another generates blinking outputs. D flip-flop is used to indicate full condition. If the ICU is not full, if if ICU is not full, the blinking signal displays bed available. Now, now the page explains the FSM or finite state machine design. FSM has present state, next state, output logic. There are 8 states because the system uses 3-bit FSM design. The state diagram shows transition between state from 000 to 111 depending on clock and reset signal. Now I'll discuss the limitation of the system. First limitation, the counter capacity is limited by the number of flip-flops. Second, the increased capacity requires the circuit. Third, overflow conditions are not handled properly. Also, the 555 timer has limited control over the piece's duty cycle and frequency. The page contains the FSM state table. The table shows present state, next state, output A and B. Output equation are simplified using Boolean algebra. These equations are used to generate the correct output for the FSM. The page shows the Verilog HDL port for the FSM output design. The module uses clock reset output signal A and B. The code updates the present state on every positive clock edges and generates output using combining logic. The, the page explains additional limitation and improvement. Finally, the page discusses LCD display implementation. Instead of only full or bed available, an LCD display the exact number of available beds. Advantage, more information, better readability, user-friendly display. In conclusion, the ICU bed monitoring system can automatically monitor ICU bed availability using digital logic circuit. The system improves monitoring efficiency and reduces manual work. Future improvements can make the system more accurate, flexible, and user-friendly. Thank you, everyone.